Hey guys, Mr. Milton here. Today we're looking at arcs and arc length notes. At the end of this video, you should be able to identify and find measures of minor arcs, major arcs, and semicircles. And you should be able to find the length of a given arc. Okay. The circle above has its center at point O. Therefore, we call this circle circle O, or O. All right. Each line segment from the center to the circle is called a radius, and each of these line segments have congruent lengths. So all radii in a circle are the same length, they're congruent. A line segment that goes through the center and has both endpoints on the circle is called a diameter. This line segment is double the length of a radius, or twice the length of a radius. Okay, the distance around the circle is called the circumference, and the formula for this is circumference equals 2 times pi times r, or you might see it as circumference equals pi times diameter. Okay, either way. Okay, arc. An arc is a portion of the circle around the outside. If you want to think about it as a pizza, an arc is the pizza crust. Okay. An arc can be a minor arc, which means it measures less than 180 degrees. An arc can be a major arc, which means the measures between 180 and 360. And an arc that measures exactly 180 degrees is called a semicircle. The measure of an arc is determined by the arc's corresponding central angle. For example, arc BC, look at it here, name arc BC, we're talking about BC up on the diagram, is made by the radii OB and OC. And therefore, the corresponding central angle is angle 57, or angle COB. And the measure of arc BC is 57. Okay. Furthermore, arc BC is classified as a minor arc because it's less than 180 degrees. Minor arcs are named with 2 letters, okay, while semicircles and major arcs are named with 3. Okay, so when we name BC, we know that it goes short, fastest way there, because it's only named with 2 letters. It says use the circle above to answer the following questions. So, first one says name 4 other minor arcs. Okay, so minor arcs, remember we said were arcs that were less than 180 degrees. And so as we look at our diagram up here, we already have CB, so let's eliminate that one. We've got DC, right, which is 90 arc DC. We've got DE, which is 28 degrees. We could call EA, even though it's not labeled with a number, we know it's less than 180 degrees because 180 degrees would be half a circle. So arc EA or AE, however you want to say that. And then arc AB. Again, don't have a value attached to it, but we do know that it has to be less than 180 degrees. And we can find that value. Okay, it says name 3 semicircles. Okay, so semicircle is going to be 180 degrees. And basically, if we have a diameter, we should be able to name a semicircle using that diameter. So let's see. Remember that as we go past a minor arc, we do need to use 3 letters. And so I'll name I have this diameter AC, so ADC. Arc ADC. Okay, because the reason we use 3 is it tells us we're going from A to D to C. Okay. Arc ABC. Okay, it goes from A to B to C. Okay, and then finally, for this answer at least, we can name another arc ECB. Again, we have some confidence in these being semicircles because we have a diameter. All right, now it says to name 3 major arcs. Remember, a major arc is just going to have measures more than 180 degrees. So a major arc, we're going to go EBA. Arc EBA. And here's the importance of naming it with 3 points. Okay, when we talk about EBA, it lets us know that we're going from E to B, then finishing at A. Otherwise, if we tried to name this arc EA, we might run into the confusion of, are you talking about arc EA this way, or are you talking about arc EA this way? Okay, and so to clear that confusion, we just always name it, if it's 180 degrees or more, we name it with 3 letters. Okay, so we have EBA, that's 1. I can see DAE. Okay, and that's not the only way I could have named that, right? DAE. I could have also called this DCE, okay, or DBE. Okay, and then finally, let's look at the last one we're doing here. Let's go BAC, arc BAC. So look, we go from B to A. Oops, circle's not that great to see. Okay. All right, so there you go, just naming our arcs, being able to do that. And hopefully with that, being able to understand when we see named arcs, what they mean from that, okay? Whether it's minor, major, or semicircles. So let's look at a few examples. It says find the value for x here. Okay, so we're going to use the information that we know about our diameters and arcs to find our value for x here. As we look at this problem, we see x written up a couple different places, but I notice that we have circle Q, so I know that this is the center of my circle, so I have a line that goes through the center and ends on the edges. This is a diameter. Okay, diameters create a semicircle, so this L and P should equal 180 degrees, and this is where we're going to get our algebraic equation from. So I can say 2x plus 3 plus 3x plus 5 plus 4x plus 1 equals 180 degrees. Okay, and so that gives me what? 5 9x plus 9. 9, yep, equals 180. Do that right? I hope I did. 5 9x plus 9. All right, great. So 9x equals 171. Divide by 9. X is not a nice number. I don't know. Maybe it is. Crazy. I would have never known that. So x is 19. Okay, so we have x 19. That's our value for x. Now it's asking me to find the measure of arc NP. Okay, and remember that the arc measure corresponds with the measure of its central angle. So the central angle is 4x plus 1. The measure of the arc is 4x plus 1. So we have 4 times 19 plus 1. So we find that that arc is 77. Again, 4 times 19 plus 1. Okay, for LK, as we look at LK, it's here. You might be like, well, there's no values here, but notice KN is also a diameter, right? So it's 180 degrees here. So what we will see, a couple different things we could see. I'll point out something that hopefully reminds us of first semester a little bit, is that you'll notice that we have some vertical angles here. Okay, so you should notice vertical angles between NQP and LQK being vertical angles should be the same. Okay, and so if NP is 77, LK should also be 77 degrees. Okay, those vertical angles. Okay, they're asking us for PK. And so, still using this diameter, we should see that this half KP in this arc should be a semicircle 180 degrees. And so with this 180 degrees, since we know that this is 77, we can do 180 minus 77 to find PK, and that's 103 degrees, the measure of that arc. And then finally, they're asking us to find LMK. LMK goes all the way out here. Okay, so L to M to K is all of this. Okay, since we already know that LK is 77, LMK must be the rest of that circle. So probably be better for us to say, okay, 360 minus 77 than to add all the information up here. Okay, so that gives us 283, maybe. Let's see. 360 minus 77, 283. All right. So we're just dealing with finding the measures of arcs, remembering that our measure of an arc is correlates with the central angle. Now we're going to talk about arc length. Okay. The measure of an arc and an arc's length are two different things. The arc length depends on the length of the radius, while the measure does not, or circumference, however you want to think about it. Ference. Okay. So an arc length is a fraction of the circumference. Okay, basically what we're doing is we're saying, what's the whole circle? What portion or what percent of the circle does this arc take up? That tells us the length of this part of the circle, or this arc. Okay, so the formula that we're going to do is we're going to do the measure of the arc over 360 times our circumference. Okay, and again, when we're talking about the measure of the arc over 360, we're saying part over whole. Okay, and so that's just giving us a percentage of the circle. What percent of the circle is this arc? Okay, so let's look at an example here. It says use circle C to answer the following questions. Find the measure of arc AB. Okay, here they notice that they're asking us for the measure. Okay, so when they ask us for the measure of the arc, we're looking for angles. Our central angle is 45. That means our arc is 45 degrees. Okay, number 2 says find the length of AB. Okay, so now we're talking about the length of AB, and that means they want to know how much string we would have here. How much pizza crust are we going to eat? Okay, so to find the measure of the arc, we need to know the radius or diameter, and they gave that to us. So what we're going to do is we're going to say, well, what's the measure of the whole outside of the circle? And so we'll do 2 pi r on that circumference, 2 times pi times 12. That whole thing is 24 pi. Okay, if it was asking us about the whole circle, this would be its circumference. But it's not asking us about the whole circle, it's asking us about this part. This part is 45 of the 360. Okay, what fraction or what percentage of the circle is that? 45 divided by 360 gives us 0.125, or as a fraction, 1/8. 1/8. This is 1/8 of the circle. 1/8 times 24 pi gives us 24 pi over 8, or 3 pi. So the length of this arc is 3 pi, I should say units. Okay. If the radius were reduced to 6 centimeters, so let's, hypothetical, and they say this is 6 instead of 12. Okay. What's the measure of the arc? Well, the measure of the arc doesn't change. The measure is just that angle. It's 45, stays 45. Okay, the length of the arc, though, changes in this way. We still have the same fraction of the circle, still 1/8 of the circle, but now our circumference is 2 times pi times 6, so our circumference is 12 pi. So we have 1/8 of 12 pi. So 12 over 8 and that simplifies to 1.5, 3 over 2, 3 over 2 pi, okay, or 1.5 pi. Last example here says find the length of arc BCA. Leave your answers in terms of pi. Okay, when you're asked to leave your answer in terms of pi, it's kind of like give an exact answer. Okay, so we'll use pi 3.1415, yada 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 forever, right? Famous pi. So we're just going to keep pi in our answer. So it's asking us for the length of BCA. In order to find the length, we need to know two things. We need to know the measure of the arc, okay, and we need to know its circumference. Okay, so let's find those two things. BCA, use a different color because this is green. BCA goes all the way out here. Okay, doesn't tell us the measure of the central angle there, but it does tell us the measure of the central angle of BA, and that's 80. So that must mean this arc is the rest of that. 360 minus 80 gives us 280. So the measure of the arc is 280. Okay, we'll notice here BO is our radius. Okay, and that is 5 centimeters. So 2 times pi times 5. So 280 over 360, if we simplify that, 280 over 360, 36 over 28, that's what, 9 sevenths, maybe? 7 ninths. Okay, I'll just leave it as a fraction. Okay, so 7 over 9, yeah, that's what it is, times 10 pi. So as we multiply 7 times 10, 70 over 9 pi centimeters squared. Or sorry, centimeters, not squared because it's length. Okay, so there you have it. You now know how to classify arcs, how to name them, how to find their measure, and how to find arc lengths. See it.